Quantum computing is a real threat to our financial system. You have probably heard about Google's 2029 deadline for quantum readiness. But this is not a hard rule, it is a warning shot. So what does this really mean for the complex financial systems that we all depend on every day? The quantum threat to finance is not a distant academic problem anymore. It is an immediate engineering challenge, focused on identity and authentication, not just data encryption. And to shed light on this, we are gonna look first why the real quantum threat is to the identity layer of the stack, not the data vault. Second, the 4 specific risk vectors that will hit financial systems first, from data harvesting to platform debt. And third, the architectural blueprint for a quantum-ready bank, focusing on agility and inventory. And by the end of this video, you will have a clear engineering focus understanding of the quantum threat to our financial systems. So let's dive in. The first thing to understand is that the quantum problem in finance is mostly related to the public key cryptography system. It is not primarily about hashes being broken. Think of your banking stack as having 2 layers, a vault layer and an identity layer. The vault layer is where you store things. It's protected by symmetric cryptography, like AES plus MAX and hashing. NIST confirms this layer is significantly less vulnerable to non-quantum attacks. It is not the priority. The identity layer is different. This is where you establish trust. It is built on public key algorithms like RSC and elliptic curve cryptography. And this layer handles certificates, digital signature, secure boots, and channel establishment. Quantum computing, specifically Shor's algorithm, breaks this identity layer completely. And that is the immediate danger. If an attacker can forge a payment instruction, impersonate a device, or sign malicious software updates, the blast radius is operational at the global level. For example, look at real financial systems. SWIFT, for example, it uses a massive public key infrastructure for authentication and digital signatures. A quantum break for public key crypto would directly hit the trust fabric that authorizes parties and signs instructions. Retail payment shows the same kind of split. For example, EMVCo, the body that manages ship card specs, uses symmetric crypto for online payments. However, for offline card authentication, it depends on public key cryptography. And my point here is that the risk is not spread equally. Online authorization is less exposed. Offline card identity is much more exposed. In a moment, I will break down the 4 specific ways this broken identity layer will cause systems to fail, but first it is important to understand this core shift, because most people see quantum computing as a confidentiality problem, but for finance it is an authenticity and integrity problem first. Now that we know the identity layer is the weak point, let's look at the 4 distinct risk vectors. First, it is harvest now, decrypt later. A cryptographically relevant quantum computing, or CRQC, doesn't need to exist today for this risk to matter. If an attacker captures encrypted traffic now and that data is still valuable in 10 years, for example, like contracts, personal data, transactions, histories, or these kind of things, then the confidentiality loss happens the moment decryption becomes possible. Finance has an unusually bad profile here due to long-term data retention. Second, and more operationally explosive, is signature forgery. This is the scenario where the system can no longer trust itself. The system can no longer distinguish a real instruction from a fake one. And this even applies to cryptocurrencies. The threat today to Bitcoin is about the digital signatures that prove ownership. For example, quantum computers could hack the famous Satoshi wallets holding more than 1 million Bitcoins. So if your public key is exposed, a future quantum computer could forge a signature and steal your funds. And this is the exact same problem. It's a failure of authentication. Third, there is a protocol and platform debt. The BIS roadmap notes that TLS 1.2 cannot be configured with post-quantum algorithms. Fortunately, TLS 1.3 can. And this means that any financial environment anchored to old protocols, outdated PKI workflows, or legacy embedded devices is structurally harder to mitigate. The challenge here is the integration of all those legacy systems, which will require a huge engineering effort. Fourth, and finally, is size and performance. Post-quantum primitives are not drop-in replacements. Their key and signature size are dramatically larger than current ECC objects. Some require more memory or more processing power. Project Leap, a recent experiment on payment systems, proved this. They found that replacing traditional signatures with PQC was feasible, but it required modifications across multiple components and revealed significant performance differences. My takeaway here is that these aren't just academic concerns. They are hard engineering constraints for any fintech production rollout. So, how are we going to move from this state of risk to a state of readiness? Well, everything starts with a good engineering plan. The G7 roadmap for finance is clear. Awareness and preparation first, then discovery and inventory. If you manage a finance institution, this involves mapping every piece of cryptography that it is used across on-prem and cloud environment, identifying the algorithm, flagging the outdated ones, and manually reviewing the legacy systems that automate tools cannot see. Second, treat cryptography agility as an architectural property. Instead of baking cryptography deep into the business logic, it must be redesigned as a replacement platform for services. For example, the Bank for International Settlements project FUSSE explored this with the microservice-based architecture. They isolated cryptography services into their own modules precisely to new methods like PQC could be this way adopted without a full platform overhaul. Here is a simple rule of thumb regarding this, and it is: if changing a signature scheme requires rewriting your payment engine, your architecture is probably the problem. And third, you should understand the likely migration path first. NIST has already standardized MLKEM for key establishment and MLDSA for signatures. Hybrid models, which combine a classical and a quantum-resistant algorithm, can be a useful temporary bridge in this case. They are going to buy us time and confidence, but they also add complexity and cost, and they are not the destination. And finally, a quantum-ready bank is a vendor management program in the end. After the inventory is done, we need to determine what you can fix internally and what depends on a third-party vendor. You need to align vendor roadmaps with your own timelines and enforce those expectations through procurement and SLAs. In other words, for a bank, we are waiting for the vendor is not a plan anymore when it comes to quantum threats. Okay, so let's bring all of this together. First of all, the quantum threat for finance is real, but it is not mystical. It is an engineering problem in the first place. It is not about breaking data vaults tomorrow. It is about breaking the identity layer today. And the first move isn't it to implement a new algorithm. It is to build an inventory and design for cryptographic agility. This is not a panic call to replace everything. Instead, it is a call to do the right thing in the right order. Prioritizing the identity layer, certificates, PKIs, co-signing, modernize your platforms before the cutover, getting rid of TLS 1.2 and other legacy dependencies. And if you work in a bank that doesn't seem to know what's going on, start by asking the questions. Where do we rely on public key cryptography for authentication or digital signatures, and what is the plan to make it quantum resistant? And if you want to stay ahead of the curve when it comes to critical engineering challenges like this one regarding quantum computing, consider subscribing to the channel for more content like this. Have a good day and see you in the next one. Bye.